Right, hello everyone and welcome to the Midas GTS webinar. My name's Adam Kane and I'll be taking you through proceedings for the day. First of all, I'd like to start by doing a quick sound check and making sure that everybody that's in the room can hear me. So if you wouldn't mind raising your hand for me or placing a comment in the comments box, I'd appreciate it. Okay, and then I'll start the presentation in about 30 seconds. Okay, I see some hands are raised, I see some comments have been passed, so that's brilliant. I also see that everybody that registered for the webinar is now attentive and in the room, so I'll just go on and start. So my name's Adam Kane, and I'll be taking through the Midas GTS presentation for finite element analysis of sequentially excavated tunnels with an intersection. I am a technical support engineer in Midas UK, based in London. And if you wish to contact us, if you are having any problems or just for a chat, then you can phone us using the details on the screen. You can also contact us via the email address. So first of all, I just want to go through some of the housekeeping rules and how to use GoToWebinar shortly after. So here we have, if you can't hear me, then you're more than likely set on mute, so hopefully you'll be able to read that and change it. If you'd like to see a full screen of the GoToWebinar dialog box, then just click on the button in the top corner, and if your screen does happen to go blank throughout, then it's more than likely your screensaver is set to on. So if you just like to turn that off or repeatedly wiggle your mouse as it goes blank. So here is the GoToWebinar box. If you click the red arrow in the top corner there, that will shrink the box down so it's just the menu, just a small menu. You can also ask questions, and what will happen is we've got a technical support engineer on standby throughout, so we'll be able to answer your questions directly. We can also respond to questions in emails after, and if we have got a time at the end of the webinar, we will be answering questions directly. So let's just go through the webinar contents. First of all, we're going to talk about the geometry modelling in Midas GTS, then we'll do some of the mesh generation, then looking at the load and boundary conditions, construction stages and post-processing. First of all, I want to talk to you about sequential excavation method. So there are alternative names like the new Austrian tunnelling method, or the NATM, or sprayed concrete lining, which is SEL. We will use abbreviations throughout. The SEM, which is a sequential excavation method, can support almost any type of ground opening, and there's many different methods of carrying out the construction. You can economise ground support requirements with your sprayed concrete and also your rock bolts. Ground surrounding tunnel is used as an integrated part of the tunnel supports as well, in the form of an arch, and the arch profile is self-supporting, and it's applicable for tunnelling in soft ground and also in rocks as well. So just some of the features of SEM. So with different ground investigations, you can carry out different support classifications. So that's why we've put the ground of excavation and support classifications. Excavation of support classes, we could do this is the different forms basically. So we've got the round length or max unsupported excavation length, supported by the shotcrete and also the reinforcement. You've got the subdivision of tunnel cross sections, so top heading, benching and invert. That means where the way you split the tunnel up into different segments. So you've got the top and also the bench at the bottom. For support installations, which are usually very round conditions in the actual tunnel, for obviously your rock bolts and also your spray concrete. You can have the pre-support by force poling, which is where you inject grout straight into the ground conditions and then carry out the excavation after, and also which is your pipe arch canopy. So the key to all of this whilst carrying out the construction is the instrumentation and also the monitoring throughout, which is also important for the investigation at the start. So we can also carry out ground improvement measures prior to tunnelling, such as freezing the ground conditions when carrying out the tunnel after. So just the basic concept of SEM. So ground supporting surrounding the tunnel is used as an integrated part of the tunnel supporting system, i.e. we were talking a minute ago about the arching effect and how the ground can be self-supporting by using the arch. Shotcrete lining is allowed to undergo controlled deflection to mobilise shear strength of ground and distribute loads. So, i.e., the ground conditions are going to affect the shotcrete itself. So as that deforms, then the shotcrete is going to deform with it, and as it rebounds as well. So at the bottom, say that all the load is distributed to the ground conditions through the shotcrete, and how that is going to have an effect reverse on the shotcrete as well. So also this is tied in with the tight contact between the shotcrete lining and the ground conditions around the outside, basically the friction and the voids that are being filled as it's being distributed along the lining of the tunnel. So then we'll talk about the shotcrete lining shares with redistributed loads into the ground by deflection, which I've just briefly talked about, is how the reaction of the ground on the shotcrete. Additional supports can be provided in the terms of rock bolts or dowels, which can be used, and also grouting can be used as well in the form of drilling, grouting and doweling. And you can also have no requirement for stiff support members to counteract the ground deformation, where you've got really good ground and stiff supports which can attract more loads and hence increase design costs as well. So the more you try and avoid putting these in place, then the lower the cost will be. So here we're going to talk about today's example. So what we have here is a tunnel and an interconnection, or a gallery that I'll frequently call it. The gallery is the tunnel is a straight through stretch of 60 meters all the way from one end, and it's split off into segments of 2 meters. Okay, which you see in the construction stage here. I'll just highlight my mouse over that just for a second. As you can see, that the ground is actually formed around the outside, and we're going to have two in ordinary fact. You normally position it in the middle of the ground, but this is what we generally do with this, is create a mirror, and then we create two tunnels, but we're just doing one tunnel for this example. So as you see the gallery and everything there, and I'll just continue. So we're just going to talk about the basic concepts of SEM. So we're just going to talk about the cross section. The shape should be activates a self-supporting arch in surrounding ground. The composer of the arch and invests soft ground conditions, so you can carry out this method both in hard ground and also in soft ground. Curvilinear shape minimises load acting on the tunnel lining. So this is what we're always talking about this arch effect, often used in bridge structures as well, where it will take all of the load away from the actual tunnel lining itself, depending on all the angles you've used and the arch form that you've used as well. You can have a flat invert at the top for competent rocks. You can also have a round invert as well for weak rocks and soft ground, which is where you'll have the tunnel lining, and then the shotcrete will distribute all the way down to the bottom, as you can see from this diagram here. Sorry, I'm just going to wiggle my mouse over the top of this for you now. Okay, so the 3D model that we've created here, the reason why we're doing 3D modeling for this section is because you've got the gallery connected to the gallery connected to the tunnel itself, so it will simulate the 3D stress regrime of the ground conditions on both parts of the connecting tunnel, which we'll show you in the results at the end. So now we're going to talk about the basic modelling. So what we're going to do first is we're going to import from a CAD geometry. We're then going to generate solids for the ground, the tunnel and the interconnection, or I will frequently call it gallery. I just want to point that out to you. We'll generate the layered stratigraphy, and we'll divide the solids for the construction sequence. So what I'll do now is I'll drag across my model, and we will start the modelling process. So just brought across the working window. I'm just going to File and just sort out the unit system. So just project settings, these are some basic output. So you just want the gravity direction and the different units you want to use. Just click OK, and that sets up the working space. Just going to import the model, so it's a DXF, and all we do is simply just double click on that and we import the file. And as you see, all the geometry layers have come through as well, so you see the tunnel, you see the rock bolts for the different sections. So what we're going to do is basically take the edge wires and create them make them into wires. This will enable us to create solid objects, so I'll just quickly do that. So we just click apply, and then as you see they've highlighted as blue, so that means that when we do extrude them they'll be the solid objects. So what we do is just move the working plane, and we move that over to the front tunnel. So now that's moved, and now we can concentrate on making a plate. So what we want to do is look at the front face, and I'm going to create a rectangle to create the ground conditions. So what this will involve is taking the rectangle, putting some of the parameters like the bottom corner and also the top corner. And you see a rectangle will appear, so I just want to click apply. So you see the rectangle's there, and what I'm going to do with all these elements now is extrude them. So I'm just going to flick the grid off and just go and select the geometry set. So just flick off the rock bolts and just go to solid and extrude. On the top there we use the ribbon technology. So we just select the wire, we select that from a drop down, and we'll start by the gallery and connecting that, just collecting the distance and call it the gallery. And there you see that's just been extruded. We're going to do something for the tunnel. So we've got the tunnel entrance, we just select the direction, the Z direction, make sure that's 60 meters, name it tunnel, and then just click the apply button. We're going to do exactly the same for the ground conditions, exactly the same distance. So just select that, 60, just select the direction, there are our solid objects. Okay, what I'm going to do now is make the solid ground into a wireframe so we can look through it. We've got different display modes, so you see that there. So just going to hide the previous edges. These are the things that we used when we did the initial extrusion. So just hide them so they don't get in the way when we're carrying out any of the modelling. And we're just going to import a BREP, which is a ground model. And we're just going to slice through and create a top strata and bottom strata, or two separate layers. Okay, and that's created our top ground and our bottom ground. I just want to rename them. So that's our bottom ground and also our top ground. So now they've been renamed, we can turn off the top layer. So that's hidden now. So what we're going to do is now I'm going to embed or create the soil structure interaction between the ground and the actual model. So I've just embedded that into the soil itself. Then we do the same for the gallery and create the interaction between the gallery and the tunnel. So we just utilised all of that, and we just selected all of it and we just embedded it, so we create that interaction. Okay, sorry, just renaming them there. Just do this quickly. So we just call that the bottom ground and also the gallery. We just want to make sure we've highlighted it so we can see it. So now I'm just going to switch to the front view. What we're going to do now is create a rectangle over this face, or over the face of the tunnel, and this is going to be used to essentially create our construction stages and everything. And we're going to use this to divide the tunnel. So I'll just quickly do that. Use the translate function and just copy it. So translate and just give it a direction, which is the Y direction, and then we just say 2 times, and we say 2 meters and 29 times. So we can preview that. So there's our preview. You can also just hit OK. Now what we'll use these plate elements. We'll delete the one at the front face. We use these plate elements to create the construction stages later on. So what we're going to do is we're going to use the divide solid by surface rule, and we select the surfaces to be divided, or the rectangles which we're going to splice through the solid, and we also need to make sure that anything touching it, including the gallery and the bottom ground, is also checked. So as you see, that's divided that now. Okay, what I'm going to do, I'm just switching the UCS to the other plane. Let's call that right. Now what I've done with this is I've switched the plane round so that I can do the same for the gallery. So exactly the same thing, rectangle, just over the face of the tunnel. Just quickly click the snaps off. There you go, just highlight that. Let's go back to the isometric view and just want to translate this 4 times, depending on how much room we have. So That's in the X direction. Just -2, then just want it 3 times. That fits. Okay. Same function, divide, so we delete the front face. Divide solid by surface. We just select the solids and we just use the works tree. This is what a really neat feature, because the works tree, you can constantly go back to it and you can highlight any of the elements within it, which is a really neat feature. You can also look at anything that's been deleted, which is untowards. So we just divided that now. Now I'm just going to drag this out of the way and take you back into the presentation. We'll just briefly talk about the meshing. So just talk about more of the basic concepts of sequential excavation method. Right, so just talking about the different constitutive models for numerical analysis. So the Mo column, which is what we're focused on today, and we've also got the Drucker, Prager, and then the Hook and Brown as well. These are other modules we have within the program. We can do the shotcrete, can also be viewed as sprayed concrete. So we've got the shotcrete limits potential for relative movement of the rock bodies or the soil particles. So say that if you've got soft ground or something like that, then shotcrete's ideal for this because it holds it back, and it also sets very quick as well, depending on the hardness you use and also the different types of reinforcement, such as plastic and also steel. Polymer reinforcement. So temporary shotcrete face, the support may be required to restrict ground from moving in excavations. So this is of course where you spray a layer of concrete or onto the face, you harden it and then you excavate it. A very wasteful procedure, but something we can do nonetheless within the program. So when the shotcrete deforms, stresses within the lining are transferred to ground, which generates subgrade reaction of the ground to the supporting lining, which effectively means that the shotcrete affects the ground conditions and it reverses back through the shotcrete, which we can monitor the stresses and also deformation throughout the whole process during the construction stages. And we consider that soft concrete with the elasticity modulus is as 1/3 of the hardened shotcrete, and we also give values for this, and it's very important in the construction stages as you go through, because as the shotcrete hardens through the process, then you can actually take the number of days it takes and everything like that, and the effect of that concrete. So just talking about the mesh generation is what we're going to focus on next in the modelling space. So generating the mesh and also creating the elements, so as the shotcrete and also the rock bolts. This will be involved in actually importing them from previous models to make it easier and more effective, which you can do the same. We're also looking at the generating the mesh for the ground, the tunnel, and the interconnection, and the shell elements for the shotcrete as well. So, and generating the supporting members. So we're going to drag the model back across now. We're just going to focus on meshing the tunnel, and then we'll mesh the gallery or the interconnection and also the ground conditions. So we're just going to import the material properties first. So those are all the material properties. Obviously got hard rock, soft rock, rock bolts, and we've also got the different types of shotcrete. We're just looking at the sections, so I just want to show you quickly the different sections that are being used for the rock bolts, and also we've got the hard ground and the soft ground, and we can show you the materials. So just go and edit, and you can change any of these obviously for the model types. Right, just to focus on the meshing of we're going to hide this first. So now we're going to focus on the meshing of the actual tunnel segments itself. So we just use the auto mesh functions of solids from the ribbon technology at the top, so we can just split it into 2 segments, 2 meters, and it'll be hard rock, and we just call this tunnel. We'll do exactly the same thing for the gallery, then also for the ground conditions themselves as well. So just quickly highlight the gallery. Same thing, just rename it. We're going to keep it consistent by keeping the same measure. So just go to the ground conditions, top ground and the bottom ground. So just going to remesh these. So just quickly select the bottom ground, 2 meters. We're just going to call this bottom ground. Obviously it doesn't matter how many different stratas you have, you can keep on selecting them, highlighting them, and then effectively creating the mesh for them. You can obviously refine it as much as you want as well. Another really neat feature, and this is all fully automated as well. It's just a simple case of selecting it and just clicking OK. So I'm going to quickly go over and show the properties in the analysis toolbar. Properties for the top and bottom, or the hard rock and the soft rock. So we've got them selected, they're just there, so if you want to select those. So look at we're just going to hide all the geometry. I just want to focus on the tunnel, because what we're going to do now is extract the shell elements from the geometry, meaning we want to just get the shotcrete from this, so the shotcrete lining. So we just want to extract the elements, we just select all, and we just want to take out the soft rock and create shotcrete from it. You see all those elements are now being created. So we'll turn off all the solids, and as you see we've got our mesh or our shell elements on the outside for the shotcrete layer. We're going to give that, we're just going to delete the plate elements at the end, the faces and also the bottom, and this will give us a shell. So that was all quickly and automatically created. So you see there we actually have the shell now, and that is the shotcrete, and that will be very important when we carry out the construction stage analysis and the construction stages, the creation. So now I'm going to focus on the rock bolts. So what I'm going to do is just quickly highlight it. I'm going to mesh them to make them into the elements that we need. So let's go to auto mesh, use the auto mesh edge function, and then select the geometry set, just go by one divide. We've got the rock bolt already highlighted, and we say tunnel rock bolt. Just click OK. Now what we're going to do is just move these a meter, because when we're carrying out obviously the excavation, if it's not in the centre, then it's not part of our actual support conditions that we're creating. So just going to move them 1 meter. So you preview, and that's just moved across. So now we've done that, I just going to translate these. So you can see there it's in a meter in. So what we're going to do is translate these and make them so they're for every single segment. So it'd be 29 times. Select direction, uniform every 2 meters, and just 29 times. You just make sure they're called tunnel rock bolts. Let's click OK. That's complete. We have all those sets in place. I'm just going to turn off all of the mesh sets. Excuse me. And just turn on the one for the gallery. So now just focus on the gallery and the rock bolts here. So just select the rock bolts. So every 1 meter, and just going to mesh them now. So gallery, rock bolts, OK, and then what we need to do is make sure that we just translate that. So just going to select the distance, select the direction. It's going to be for 7 meters, and we're going to translate it as 7 meters. It's going to be 3 at every 2 meters. So the distance is 7, as you see there. I just want to delete the previous one. Okay, now that is all of our mesh sets been created, and also all of our rock bolts for all of our different locations. So let's quickly highlight them. We're just going to highlight that they're actually in the right location. So they are in the right location now. So I'm just going to turn on all the mesh sets, go back to the isometric view. So just going back into the presentation mode now, so just drag this out of the way and quickly go through. So we're just going to talk about the loads and bound conditions, and first of all we're going to put the self-weight loads on. Then we're going to do the surcharge load, and we look at some of the boundary conditions as well, and the support conditions in all the directions. So just take you back into the modelling space, and we'll carry this out. First of all we'll start with the self-weight. So just go to analysis, loads, adds, and just add the self-weight. So just be in self-weight and in the -1 in the Z direction. Okay, now we're just going to do loads again and add a pressure load to the surface. So let's call that pressure load, and we just select the face, the top face, the element face, so the top of the ground condition. Then we just select 75 kilopascals. Then we just want to preview that. As you can see, the load's applied to the top. Just go to OK, and now that load's been applied. Okay, I just want to switch those off and just add the supports and boundary conditions. So call it supports, make sure we've got it in the X direction. So just first of all, we'll just highlight the two edges we want to focus on and make sure it's highlighted in the UX direction. And we're going to do the same for the Y direction, and then exactly the same for the Z direction at the bottom of the model. Let's go to the side view and do the same thing. So it's automatically creating these support springs all the way around the outside. Okay, it's been created. So I'm just going to turn off the supports now, so we can focus on the mesh sets for the shotcrete, soft shotcrete, and also the hard shotcrete. So the construction stage analysis to give it more of a realistic appeal. So I just want to turn the tunnel back on, make sure we've got the gallery and the tunnel. So we just go over, just want to go to boundary conditions and add. I'm just going to change the element parameters. And that's the shotcrete hard there, so just click OK. You can see that's been highlighted. And this will come in, this will be important for when we do the construction stage analysis. Now we're going to go back over to the presentation view and just discuss this. So just talking about the construction stage analysis, first of all we're going to go to the stage definition wizard, then we're going to look at the stress initialization and the nonlinear analysis control. So just going to show you a brief video. Now this is construction stage analysis being carried out. As you can see, the segments are being removed, the shotcrete is being implemented, and also the rock bolts are being implemented as well. So now going back to the model view, I'm pulling up the construction stage wizard. So construction stage definition, I'm just going to add a few construction stages. So initial will be the first one. Right. So just take over some of the elements, some of the boundary conditions and the gallery. So the gallery brought over, the tunnel will be brought over, and also the bottom ground. Some of the tunnel segments. So top and bottom ground, so just looking for the top ground. So let's go down. And the south weight's got to go over as well. Okay. So just look at the clear displacement. Click OK. Now we're going to go to the next construction stage. Let's go pressure load. So this is where we'll have the surcharge on the surface of the top layer. So the pressure load will be our load. Then we go on to the next stage. So that'll be excavation. This is when we're carrying out the excavation of the first segment. So it'll be just the tunnel 1. We go into the deactivated data. Then we save that, and then we go on to the shotcreting stage. So excavation 2. So what we're doing here is moving the tunnel 2, which will be in the deactivated. Tunnel 1 will be in the activated, and the rock bolts will be in there as well. So that's the tunnel shotcrete. So 1, so that is now activated. So that's 3 stages I've just done now. I'm now going to go to the post-processing stage and just show you all of the construction stages that are already filled out, and we'll just flick through them as well. So just pull up the meshes, just hide those, and then we're just going to look at the construction stages throughout all of these. So just simulate the construction stages. As you see there, we just pulled that up. Give you time. You can also just flick through by using the slide rule, which is a really quick and efficient way of doing it. So we can just go step by step all the way through from start to finish and look at each different construction stage. So let's get rid of that. Okay, now we'll just go back to the presentation and we'll just focus on the post-processing. So in the post-processing, we'll look at some of the report-ready results. We'll look at extracting the results from the construction stages. We'll look at the settlement profiles, the deformations and displacements. We'll also look at the forces and moments in the structural members in the form of the rock bolts and the shotcrete. And we'll also look at the cutting planes. So going back to the model, and we'll just pull that back across now. So now I'm just going to turn on all of the mesh sets within the model. Then we'll just focus on the displacements and we'll look at the displacement throughout the whole model. So just going to bring out the post-analysis. Then we can go through different stages. So you can see here just step 1. So we can look at the displacements in the DX and the total displacement, sorry, and go through the different construction stages. Now keep on flicking through. Okay, well, what I've done here, I haven't got the contour plot selected, so I just got to go and post command and just pick up the contour plot. So there you go, back into the original view, and now we can look through it through the construction stages and flick through, and as you see that they're disappearing there. You see the tunnel being created and also displacement being all through the soil there, as you can see in the contours. So we can look at it for different values. So you can go on the DX and you can just look through all the construction stages. It's a really neat feature. You can flick through and really visualize where the displacement is actually occurring. So we're going to continue looking at displacements and just flick on all of the mesh. So you see all the meshes highlighted now. Now I'm going to do some tagging. This means where we can just select any point on the soil conditions, and we can check the deformations throughout. So literally anywhere on the geometry you can select, and it will bring them all up in a tabulated format as well. So I'm just going to close this window. Just look at the front face. Let's go to results and look at extract the results from the results table. And we just look in the DZ direction. What we're going to do is we're going to focus on the tunnel crown. So we're just going to highlight that, and we're just going to extract the displacement in the vertical direction. So now it's got that highlighted. It's just going to take a couple of moments. Just a really neat feature, and we can look at all the results tables and the displacements throughout all the construction stages as well. You can also look at this in a graphical form as well. So we just go to graph and we just go to sort. So here you see in the graphical form the displacement which is actually occurring. So just going back to the isometric view, I'm going to flick off some of the edges for the tunnel. So go back to the pre-processing mode, just going to turn these off so we don't visually see them. So just turn off some of the tunnel edges, look at the construction stage 3 now. Then we can look at it from the contours, so looking at all deforms, and then we're going to look at the post-process and do some of the slicing planes through it. Now this is a very neat feature, it's all automated and very easy to use. We can just add different clipping planes just by moving it across and clicking the add button. So as we click OK, then you can see that there's different planes are being created. So we just add them one at a time. And what you can do, you can activate all of these in one simultaneous motion. We can also flick the incline, we can go in the Y direction, the X direction. We can also look at this throughout every single construction stage. And you get a very good, an excellent visualization of what is happening within the working space. To just apply, and as you can see there, all of the clipping planes have been created. We take off the edges, and I just want to go through the construction stages. You see the stress going through and the displacement going through all of the members. Now we're going to look at the clipping plane. So let's go to, same again, post command, clipping plane. And we can just create this, we can define it so we can move it across wherever we want. And as you can see there, you can take it all the way through the tunnel. You can also select different areas as well. So if you want to do more than one clipping plane, you can do that. We're going to look at the deform shape and do that through all the different construction stages. As you can see here, as the tunnel is being created, and that's the lining there being created. And you can look at it from any different view and see the visualization of the contours, which is a superb visually. You can even look at the wireframe as well, where you can see the gallery and the tunnel. We can also create multiple isosurfaces, so I just want to create that now. So what we can do, we can nominate values and we can add them. So as you see, we've got a slide rule here, and we can just go all the way across and just keep on adding them. And when we go to visualize them, they will come up in all different manner of contours across the model. More excellent visualization. Also it shows abstraction as well, as you can get this in a tabulated format. As you can see there, those are the actual contours that come out. Okay, and you do that for the undeformed shape, the deformed shape. You can do it for all the construction stages, visualize it and see where everything's actually occurring. Now I'm going to look at the settlement profiles. So just go for the post-processing, go back to the original view, and we'll just select the top. So we just want to highlight the grid on again, and we just select the plane. So we just want to select it by the 3 points, and we just want to save that as top. Let's click the OK. We're going to get the settlement profile at the top of this. So we've already got our plane, and we just select it again. We can select 2 points, and then we can just add that, and that's our grid. So now that we've created that, we can just isolate it and just look at the settlement profile through the plot. So as you can see, you can look at it in the DZ direction, and we can also look at it through the different construction stages as well. So as you can see visually there, looking through the construction stages, and also get that in a tabular format. So that's through and we can look in the Y direction, just go to a different construction stage. You can look at different plots. Okay. So now we're going to look at the forces in the shell element. So just to stop that, let's go to the model, and we just got to highlight it from the works tree. Make sure we just got all those shell elements selected. So I just want to, when I right click, I can just go show only, and we're just going to focus just on this. So these are the forces in the shell elements. So we just select that from the drop down, just highlight it. Then we can just go play it in the MY, and we just look at it through the different construction stages and see the forces going through each different segment as it's built up. You can look at it in different directions as well, FYY, FZZ, MYY. So there you have that. Now I'm just going to look at one of the mesh sets, and we just want to look at the front face. So we just want to just show only. So we're going to look at this. Just going to post command. We just want to look at the edges. Then go to the post-processing data, the results, and just go on to the on-curve diagram. Now what we do here is we just select the 2 points and create the on-curve diagram. So we just selected a very small point at the side there, and we just give it a name. Then we can just add that. Just call it 1. Then we can look at the diagram for it as well. So you see there that the stresses are being created at the bottom of the structure. What I'm going to do is draw multiple on-curve diagrams to the center, just so we can get the moments throughout the whole thing. So just to add each one, and we can display them all at the same time. So just give them a different name each time. Just take a couple of moments. So each one we got to select going all the way through. And we're just going to do this to the center just to make it nice and simple and a bit quicker. So just add that. Just make sure we select the right direction. Okay, now we have all 5 of these. Let's look at the diagram. As you see, we can see the forces there throughout the member in different directions. We're now going to look at the forces in the rock bolts only. So we're just going to go back to the model and space in the works tree and just select them from this working window. See, we just want to show them only. So as you see, we've got the rock bolts there. We're just going to focus on the forces. So just go back to the post-processing, and we can look at this through all the different construction stages. As you see, the legend is changing with the forces changing throughout. Okay, and there's a good visualization from the front view as well. So I'm just going to show you different views. Let's go back to the pre-processing. We can just make sure we've got all the mesh sets back on. That's okay. Now what we're going to do is take you back to the presentation and finish off. So, thank you to everybody who attended. I really do apologise for going over the time. I know we're at about 37 or 38 minutes now when it said 30, so I won't be able to answer any questions during this session. We will be sending out a detailed answer for you in an email form, because I know that we have had a few questions in. If you do wish to contact us for a big bespoke demonstration or just a general query about what Midas can do for you, then please do call in or email in using the address provided on the screen there. I'm going to leave this up for a few minutes longer, but for now, my name's been Adam Kane, and thank you for attending, and I look forward to speaking to you soon and well, hopefully dealing with you soon. So thank you very much. I'll just sign off.